Hello, today our topic is AWT class hierarchy. AWT means Abstract Window Toolkit. Java AWT, that is Abstract Window Toolkit, is an API to develop a graphical user interface, that is GUI, or window based applications in Java. Java AWT components are platform dependent, that is, the components are displayed according to view of operating system. AWT is heavyweight, that is, its components are using the resources of underlying the operating system, that is, operating system means OS. It is also heavyweight, implying that its components are using the resources of the operating system. Java.awt.package provide the classes for AWT API. For example, text field checkbox, choice, label, text area, radio button, list, etc. The next one is, what is the purpose of AWT? Java AWT means Abstract Window Toolkit is an API to develop GUI or window-based applications in Java. Java AWT components are platform dependent, that is, components are displayed according to the view of operating system. AWT is heavyweight, that is, its components are using the resources of OS. OS means operating system. Next one is, what are the features of AWT? A robust event handling model, graphics and imaging tool including the shape, color and font classes, layout managers for flexible window layout that do not depend on a particular window size or screen resolution, data transfer classes for cut and paste through the native platform clipboard. The next one is, what are the advantages of Abstract Window Toolkit? It takes very less memory for a development of GUI and executing programs. It is highly stable as it rarely crashes. It is dependent on operating system, so performance is high. It is easy to use for beginners due to its easy interface. Why AWT platform is independent? Java AWT calls the native platform operating system subrouting for creating API components like text field, checkbox, button, etc. For example, an AWT GUI with the components like text field, label and button will have a different look and feel for the different platforms like Windows, Mac OS and Unix. The reason for this is the platform have a different view for their native components, and AWT directly calls the native subrouting that creates those components. In a simple word, an AWT application will look like a window applications in Windows OS, whereas it will look like a Mac application in the Mac OS. The next one is, what is the Java AWT hierarchy? Java AWT hierarchy consists of a component which include container, button, label, checkbox, choice and scroll bar. In container include window and panel, while window is include frame and dialog, while panel is include an applet. This is about the AWT hierarchy. We are discussing in detail one by one. First one is the components. All the elements like button, text field, scroll bar, etc. are called components. In Java AWT, there are classes for each component as shown in diagram. In order to place every component in a particular position on a screen, we need add them to a container. Containers are an integral part of AWT GUI components. A container provides a space where a component can be located. A container in AWT is a component itself, and it adds the capability to add the component to itself. We are considering some noticeable point for container is subclasses of container are called as a container. For example, panel, frame and window. Container can add only component to itself. A default layout is present in each container which can be overwritten using a set layout method. Basic method of component class. First one is public void add. Component C. This method would insert a component on this component. Next one is public void set size, int width, int height. This method would set the size, that is width and height, of a particular component. Next one is public void set visible, boolean status. This method would change the visibility of the component, which is by default false. Next one is public void set layout, layout manager. This method would define the layout manager for the particular component. Next one is a container. A container is like a screen wherein we are placing the component like button, text field, checkbox, etc. In short, a container contains and controls the layout of components. A container itself is a component shown in a above hierarchy diagram. Thus, we can add a container inside the container. Containers are the integral part of the AWT GUI components. A container provides a space where a component can be located. A container in AWT is a component itself, and it adds the capability to add the component to itself. Container can add only component to itself. A default layout is present in each container, which can be overwritten using setLayout method. Basically, the container class is a subclass of a component. It has an additional method that allows the other components object to be nested within it. Other container objects can be stored inside of a container since they are themselves instance of a component. This makes for a multi-leveled container system. A container is responsible for laying out, that is positioning, any component that is contained. It does not this through the use of the various layout managers. And in short, what is meant by component? Component is an abstract class that encapsulates all of the attributes of a visible component, except for a means all the user interface elements that are displayed on the screen and that interact with the user are subclass of component. It defines over 100 public methods that are responsible for managing the events, such as mouse and keyboard input, positioning and sizing the window, and repainting. A component object is responsible for remembering the current foreground and background colors and the currently selected text font. The next one is, what are the types of containers? A container is the place wherein we add the components like a text field, button, checkbox, etc. There are 4 types of containers available in AWT, that is Abstract Window Toolkit. First one is window, frame, dialog, and panel. As shown in a hierarchy diagram above, frame and dialog are the subclasses of the window class. First one is a window. We discuss one by one in detail. First one is a window. The window is the container that have a no border and a menu bars. You must use frame, dialog, or another window for creating a window. We need to create an instance of window class to create this container. A window class creates the top level window. A top level window is not contained within any other object. It sits directly on the desktop. Generally, you won't create a window object directly. Instead, you will use a subclass of window called frame. Window is a rectangular area which is displayed on the screen. In a different window, we can execute the different program and display different data. Window provides us with a multitasking environment. Then, what is the class declaration is used for window? Is public class window. Next one, extend container, implement accessible. This is the class declaration used for a window. The next one is a class constructor and description in window. First one is window frame owner. Construct a new initially invisible window with the specified frame as its owner. Next one is window owner. Construct a new initially invisible window with the specified window as its owner. Third one is window owner graphic configuration GC. Construct a new initially invisible window with the specified owner window and a graphic configurations of a screen device. There are various class methods are used in window. First one is void add notify. Make this window displayable by creating the connection to its native screen resource. Void add property change listener. Property change listener. Add a property change listener to the listener list. Next one is void add window listener. That is a window listener first. Add the specified window listener to receive the window event from this window. Then next type of container is panel. The panel is the container that does not contain title bar, border or menu bar. It is a generic container for holding the components. It can have other components like button, text field, etc. As an instance of panel, class creates a container in which we can add the components. Panel provides the space in which an application can attach any other component including any other panel. The panel class is a concrete subclass of a container. A panel may be thought of as recursively nestable concrete screen component. Panel is a subclass for an applet. When screen output is directed to an applet, it is drawn on the surface of a panel object. In essence, a panel is a window that does not contain a title bar, menu bar or border. This is why you don't see these items when an applet is run inside a browser. When you run an applet using an applet viewer, the applet viewer provides the title and the border. Other components can be added to a panel object by its add method. Once these components have been added, you can position and resize them manually using the set location blank bracket, set size blank bracket, set preferred size blank bracket or set bounds blank bracket method defined by the component. Then what is the AWT class panel declaration? Public class, public extend, container, implement, accessible. This is the AWT panel class declaration. Then let us consider the one example of panel, that is a Java AWT panel example. The code is to represent the Java AWT panel example. Import java.awt public class panel example include frame f is equal to new frame in bracket panel example. Panel is equal to new panel dot set bounds from 40, 80, 200, 200. Panel dot set background include color dot gray. Button b1 is equal to new button include button 1. b1 set bounds from 50, 100, 80, 30. b1 set background color yellow. Button b2 is equal to new button 2. b2 set bounds, that is 100, 100, 80, 30. b2 set background, that is a color green. Panel add b1 panel dot add b2. f dot add panel f dot set size 400, 400. f dot set layout null. f dot set visible true. Curly bracket complete. Public static void main string args in curly bracket new panel example curly bracket close. This is a program which is used to represent AWT panel example. The output of this is panel example, that is the first button contain the background color yellow and button 2 contain the background color is green. We are mentioned in example in code. First panel is of gray color, then we set the button 1 of yellow color and button 2 of green color, and the frame is generated, is called as a panel. This is the output of this code, this example. The next one container is type of container is frame. The class frame is the top level window with border and title. It uses border layout as default layout manager. The frame is the container that contains title bar and border and can have menu bars. It can have other components like button, text field, scroll bar, etc. Frame is most widely used container while developing an AWT application, that is an abstract window toolkit application. Frame is most widely used. Frame encapsulate what is commonly thought of as a window. It is a subclass of window and has a title bar, menu bar, border and resizing corner. This is all about the frame. Then what is the class declaration used to represent the frame is public class frame, extend window, implements menu container. This is the class declaration we use to represent the frame. Then our next topic is the field for java.awt.frame class. The following are the field for java.awt.frame class. First one is static float bottom alignment, ease of use constant for git alignment y bar, alignment y. Then next one is static int cross hair cursor, deprecated or replaced by cursor, crosshair slash cursor. Static int default cursor, deprecate replaced by cursor. Static int e resize cursor, deprecate replaced by cursor. E hash resize underscore cursor. Static int hand cursor, deprecated replaced by cursor, hand underscore cursor. Static int iconified. This state bit indicate that frame is iconified. Static int maximize both. This state bit marks indicates that frame is fully maximized, that is both horizontally and vertically. Static int maximized horizon. These state bits indicate the frame is maximized in the horizontal direction. That is static int maximize vert. This state bit indicates that frame is maximized in the vertical direction. Next one is static int move cursor, deprecated replaced by cursor, move underscore cursor. Static int n resize cursor, deprecate replaced by cursor, n underscore resize underscore cursor. Static int any underscore resize cursor, deprecated replaced by cursor, any underscore resize underscore cursor. Then next one is static int n resize cursor, deprecate replaced by cursor, n underscore resize underscore cursor. Static int n e underscore resize cursor, deprecate replaced by cursor, any underscore resize underscore cursor. Static int normal, frame is in the normal state. Next one is static int nw underscore resize underscore cursor, deprecate replaced by cursor, nw underscore resize underscore cursor. Static int s resize cursor, deprecated replaced by cursor, s underscore resize underscore cursor. Static int sc underscore resize underscore cursor, deprecate replaced by cursor, sc underscore resize underscore cursor. Static int sw underscore resize underscore cursor, deprecate replaced by cursor, sw dot resize dot cursor underscore cursor. Static int text underscore cursor, deprecated replaced by cursor, text underscore cursor. Static int w underscore resize underscore cursor, deprecated replaced by cursor, w underscore resize underscore cursor. Static int weight underscore cursor, deprecated replaced by cursor, weight underscore cursor. This is the all about the fields for java.awt.frame class. Then how we can work with a frame window. After the applet, the type of window you will most often create is derived from the frame. You will use it to create child windows within the applet and the top level or the child window for the standard alone applications. As mentioned, it creates a standard style window. Here are two of frame constructor, that is a frame through headless exception or frame in bracket string title those headless exception. The first form creates a standard window that does not contain a title, and the second form creates a window with the title specified by a title. Notice that you cannot specify the dimension of window. Instead, you must set the size of the window after it has been created. A headless exception is known if an attempt is made to create the frame instance is in an environment that does not support user interaction. There are several keys methods when we working with the frame window. First one is setting with the frame dimensions. The set size null bracket method is used to set the dimensions of the window. Next one is how we can hiding and showing a window. After a frame window has been created, it will not be visible until you call set visible null bracket. Its signature is shown here is void set visible in bracket boolean visible flag. The component is visible if the argument to this method is true, otherwise it is hidden. Then how we can setting a window title? You can change the title in a frame window using set title null bracket, which has this general form, that is a void set title in bracket string new title. Here new title is the new title for the window. How we can closing the frame window? Our next topic is how we can close the frame window. When using a frame window, your program must remove that window from the screen when it is closed by calling set visible false. To intercept a window close event, you must implement the window closing null bracket method of the window listener interface. Inside the window closing null bracket, you must remove the window from the screen. You must remove the window from the screen. Then next one is how we can creating the frame window in an applet. While it is impossible to simplify the creative window by creating the instance of frame, you will seldom do so because you will not be able to do much with it. For example, you will not be able to receive or process an event that occur within it or easily output information to it. Most of the time, you will create a subclass of frame. Doing so let you override frames method and provide the event handling. Generating a new frame window from the within an applet is actually quite easy. First, create a subclass of frame. Next, override any of the standard applet method such as init null bracket or start null bracket and stop null bracket to show or hide the frame as needed. Finally, implement the window closing null bracket method of the window listener interface, calling the set visible in bracket false. When the window is closed, once you have defined a frame subclass, you can create an object of that class. This causes a frame window to come into existence. But it will not be initially visible. You make it visible by calling set visible null bracket. When created window is given a default height and width, you can set the size of window implicitly by calling the set size method. A window of this subclass is instantiated within the init method of an apple frame. Notice that the sample frame called frames constructor. This causes a standard frame window to be created with the title passed in title. This example overrides the applet start and stop method so that they shows and hide the child window respectively. This causes the window to be removed automatically when you terminate the applet. When you close the window, or if using a browser, when you move to the another page, it also causes the child window to be shown when the browser returns to the applet. This is all about the how we can creating the frame window in an applet. So, in today's lecture, we are discuss about the AWT class hierarchy. AWT class hierarchy is mainly consist of the component. In component that include the container, button, label, checkbox, choice, and scroll bar. In container include window, panel, and window is include frame, dialog, and panel is include applet. This is all about the AWT hierarchy in Java. We are discussing in this lecture detail about what is the container and what are the types of container and what is the component. Thank you.